All right, so let's look at hypothesis testing or inferences. What is a hypothesis? Who can tell me another synonym word? What's synonymous word for hypothesis? You can tell us. Everybody is going to talk here. I'll start from the bottom. Who is having the name Zoom user? Who is having the name Zoom user? Who is having the name Zoom user? So that person should bounce back at me later. Next person, Valentina Gokel. Are you there? Gokel.
Hello, sir.
Yes, what is a hypothesis?
Hello, sir. Please can you...
Yes, what is a hypothesis?
So, a hypothesis is a statement about a particular population parameter, or it's an assumption about a parameter.
You are reading. You are reading. If a 7-year-old should ask you what is a hypothesis, how will you say it? Stephen.
Sir, please, it's an educated guess based on observation.
Very good. That is good. That is a hypothesis. What other synonyms do you have for hypothesis? I'm taking it slowly so that you can get it. And to go slowly, you've got to just be addressing my question. Because if you are not able to answer my question, I will not be able to go slowly. I will assume that you know. Yes, feedback.
Sir, I'll say assumption.
No. What else? Vanessa.
Say prediction.
Prediction is good. Emmanuel.
So I'll say theory.
Theory, no. Prediction is okay. Theory, no. Emmanuel. Forecast. Forecast. Conjecture. Conjecture. Speculation. So these are ways you can think about hypothesis. All right. Now, there are, in statistics, a hypothesis is a claim. It's a claim. But a claim about something, it's not just a claim, but it's a claim about something. Any statistic, a claim about it. You can convert a hypothesis, which is a statement, to a question. So whenever you're doing your research question, you can either make your research question a question, or you can make it a statement. And when you make it a statement, it becomes a hypothesis. It's a hypothesis. Let's take, for example, if I say that income has a positive effect on consumption, is this a statement or a question? Income has a positive effect on consumption. Is that a statement or a question? You can tell us.
This is a statement.
Raise your hand. Raise your hand. It helps. Amina.
Sir, please, it's a statement.
Why?
It's stating that income has a positive effect. It is telling you. It is not asking a question. It is telling you that it has a positive effect on consumption.
So how will you convert this into a question? How will you convert this statement into a question? Ebenezer.
Does income have a positive effect on consumption?
The next one. Next one is it a statement or a question? Next one, is it a statement or a question? I don't want to read it, but when I read it, you will know. That's why I'm just asking you. Aditya.
So it's a question.
And my question to you is that who can convert this into a statement or a hypothesis? Who can convert this into a hypothesis or a statement?
Sir, please, can I try?
Socially responsible firms are more profitable.
Excellent. Socially responsible firms. Excellent. So a hypothesis can be converted into a question, and then a question can be converted into a hypothesis. Keep that in mind. Now, let's look at some ways of handling hypothesis. You can do hypothesis testing, and you can connect hypothesis testing into a confidence interview. At your proper master's degree course, you will do that. But before you will do hypothesis testing, there are steps to take. There are 4 steps to take. Write it down. There are 4 steps to take in hypothesis testing. And we'll be talking about these 4 steps very soon. So if you're having a pen, write them down. Okay, we'll talk about the 4 steps very soon. One of the steps will require you to determine the tail of the test. One of them will require you to identify the tail. Now, what do we mean by the tail of the test? Well, the tail of the test is basically whether the test is a one direction, which is a one tail, or a two direction, which is a two tail. The best way to understand this tail of the test is by giving you an example. So let's take an example. Suppose I say that she is bigger than 60 kilograms. She is bigger than 60 kilograms. Is that one direction or two direction? What do you think? She's bigger than 60. Compare that with she is 60 or less. So Wallace, what would you say? Wallace, your hand was up, or Ebenezer?
So it's one direction.
Why?
Because it doesn't give a second condition. It just said she is bigger than 60 kilograms.
Very good. Very good. That one direction means that you cannot come below 60. That's what it means. You cannot come below 60. You are going to be one way. However, when you say that she is not 60 kilograms, why is that a two-directional? She is not 60 kilograms. Why would you say that that is a two-directional way or a two-tail? Mama.
Sir, because she can be either more or less than 60.
Exactly. Now, there are symbols that actually reference these words I just used. For example, we all know that this symbol is what? The symbol I've just written right now. What is the name of this symbol? This symbol, what is it? You can tell us. What is a common name for this symbol? Quality.
So less than.
It's a less than symbol.
I didn't call you. Next time, raise your hand. It's Allote I called. Now, what is the opposite of this symbol? What is the opposite of this symbol? Raise your hand. And tell. What is the opposite? Ivy.
Greater than.
No. Unfortunately, statistically speaking, greater than is not the opposite of less than. What is the opposite of?
Wow.
Please mute yourself, and when you are calling, then you talk. Literate.
So equal to.
No, it's not equal to. What is the opposite of less than?
No.
What is it?
Oh.
Please don't be giving multiple answers. Once I call you, raise your hand back again, Valentina.
Sir, greater than or equal to.
That is correct, but that is coming from the mistakes others have made. That is what has given you this option. So, guys, you should know that opposite of less than is never greater than. It's rather greater or equal to. Because if I say she's less than 60 kilograms, okay, and you say that the opposite is she's greater than 60, then it means that you have not put 60 on the number line. Less than 60 means below 60. Greater than 60 means above. So why will you put 60? If you want to include 60, you have to say she's greater or equal to 60. Okay, very good. What is the opposite of not equal to? Not equal to. That one is easy. What is the opposite of not equal to? You know, sometimes when you feel like everybody knows the answer, that's when you know that everybody doesn't. So sometimes you have to raise your hand. Not because you think everybody knows.
Say equal to.
Equal to. What is the opposite of greater than?
Less than or equal to.
Very good. So keep these things in mind. The symbols here, the one tail test always carry the less than or equal to or greater than or equal to, all of those symbols. And then the two tail test is the one that carries the not equal to and its opposite. So keep that in mind. So when I say that, listen carefully, when I say that beyond, which symbol am I actually talking about? Beyond. If I say beyond, if you look at the symbols, which symbol really am I talking about? Beyond. Ebenezer.
Say greater than.
Very good. What if I say above? Above. I'm starting with the easier ones. Above. Nana.
Say greater than.
Very good. What if I say at most? At most. At most. At most. Emmanuel.
Less than or equal to.
Less than or equal to. Very good. What if I say not at least? Not at least. Be careful. Be careful. Not at least. That means we are talking about the opposite of at least. That's the meaning of not at least. What will be the opposite of not? What is not? Opposite of at least. Anastasia.
Greater or equal to?
No, that will not be correct. What is not at least? Stephen.
Greater than.
Greater than. That is incorrect. What is not at least? The moment you know you are doing lottery, then you shouldn't bother. Amina.
Sir, please, less than.
Okay. Are you sure what you said?
Yes, please.
Explain. Explain.
Okay. So not at least, that is, it is not up to what you are looking for. It is below what you are looking at. That's my understanding of not at least.
I'm taking it directly, but you should always break it down. What is at least? What is at least? When you look at least, what is at least? What is at least? Yes, Ebenezer.
Say less than or equal to.
Less than or equal to. That is not at least. What is at least? Naya. Huh? Naya, your voice is far away.
Sir, please, can you hear me?
Uh-huh.
Not at least. Sorry, not at least or at least. What was the question?
At least is what I'm asking.
At least. Greater than or equal to.
Okay. So, what is the opposite of greater than or equal to?
Less than or equal to.
No, that's wrong. What is the opposite of greater or equal to? Ebenezer.
Say less than.
Less than. So you see, if you analyze it from the fact that the word not should not be taken into consideration. Just deal with the at least first. And then you ask yourself, the not is the opposite after you've written that. Very good. What symbol do you think is for differs from? What symbol is differs from? What symbol is it? Differs from? Theo?
So please, that means it's not equal to.
It's not equal to. What symbol is the same as? The same as Theo?
Pardon?
What symbol is the same as?
So you said what symbol is the same as? Equal to. Equal to.
What symbol is worse? Who can tell us worse? Theo is getting tired. What symbol is worse? Worse. What symbol is on? Equal to. What symbol is off? Equal to. What symbol is worse? Equal to. Write them down. You need them. You need them also in the exams. All right. So these are what we mean by hypothesis tales. Hypothesis. Now let's look at the steps in hypothesis testing. Now, if you write them down, you remember them better. So you write them down. Step 1, write the null and the alternative hypothesis. That's step 1. Write it down. Write it down. Write it down. The step 1 is to write the null and the alternative hypothesis. Step 2 is to calculate the test statistic. That's step 2. Calculate the test statistic and the critical value. Calculate the test statistic and the critical value. That's step 2. Step 3 is to find the p-value and alpha. Find the p-value and alpha. And the final step is to decide and conclude. Decide and conclude. What I'm going to do now is to take a simple example to demonstrate all these steps for you. Yes, Amat.
Sir, please, the third one, find the p-value and what the alpha.
Yes, alpha. Alpha
Okay.
is the level of significance. The level of significance, that's alpha. So, I mean, I have a question.
You said the line was breaking on my end. You said alpha is the level of
Significance.
You said?
So let me explain some few things to you to make things better. For example, the null and the alternative hypothesis, which is inside the step 1. The null hypothesis is the authoritative statement. The alternative hypothesis is the alternate statement. It is a mirror image of the null. It's the opposite of the null. Now, whenever you are formulating a hypothesis, the way to do it is what I'm about to tell you. And I'll just use one example to show you. So let's say that there is this statement that says that Nescafe Ghana claims that since the population mean filling weight is at least 3 pounds per ton. Watch the word. Since the population mean filling weight is at least 3 pounds per ton, consumers' rights are protected. So that's the statement. You're about to write a null and alternative hypothesis. What you got to look for is the word average or the word mean. You take that here. Underline that. You're also looking for a word that can be symbolized with less than, greater than, less or equal to, greater or equal to, or not equal to. Which word here carries the idea you are looking for? Which word, is the symbolic word? Which word?
At least.
At least, very good. You underline that. And now, this is how you write a null hypothesis. You are going to, remember, you are talking about the mean, so you will always write mu, and then you leave a space, and you write the number that was given. The number that was given is 3 pounds. The number is 3 pounds, so you just write 3 pounds. Then you do the same thing below it, mu, and then again, you write 3 pounds. You're about to formulate the null and alternative. Then you will bring colon in front of each one of them, in front of the mu you have written, you bring colon. Then you look for that symbolic word, and then remember the symbol for the word. So what is the symbol for at least? Be careful, we've gone through this already. What is the symbol for at least? You can tell us. What symbol is at least? Naya.
Say greater than or equal to 3.
So you will write that greater than or equal to 3 without bothering yourself where you are writing it. You just give it to one of them. And then you ask yourself, what is the opposite of this symbol I just wrote down? That's what you ask yourself. And then you answer it. So you can tell me, what is the opposite of a symbol we just wrote? What is the opposite of that symbol? What is the opposite? Nanama.
Greater than.
No, that's incorrect. Ebenezer.
Less than.
Say
Sorry.
less than.
So
So
now
sorry.
you write the less. You got to pay attention. That's the only way you will not make some of this. Once you've written the less than, you step back. And I want you to write this down in your note. Write this down. Because at this stage, you are about to identify which one is a null hypothesis and which one is an alternative hypothesis. And the rule is that the null hypothesis always has some level of equality in it. Write it down. The null hypothesis always has some level of equality. The null always has some level of equality in it. So let me ask you, on the basis of this, which one is a null? Is it a top one or the down one? Is it? Which one is a null? Is it a top or down? Start.
Say the top one.
Very good. So you write H naught for the top one, and then you write H A for the down one. You have just formulated the null and alternative hypothesis for the statements in English above. You just did. If you want to try, false. So let's say that you have another statement that says that Max Flight uses a high-tech manufacturing process to produce golf balls with a mean driving distance of 295 yards. What is a null and alternative hypothesis? You can just state it, because you have to think through it. You can just tell me the null and alternative hypothesis for this statement. You may have to put certain things down, be sure what you've done. Yes, Ebenezer.
Say H0 is equal to
It's not equal
295.
to. The word is not equal to. H0 what? You should never mention that H0 first. If you remember the way I taught you, you got to do it backwards. Or you've done everything backwards and you want to say it. Naya.
Yeah, so I think the word here is off, so which is an equal to, so it will be mu equals 295 yards, and then the alternative hypothesis will also be the same thing.
No, it won't be the same thing. The alternative hypothesis will not be the same.
Hey, sorry, it's would be not equal to, sorry.
So say everything. Finish everything.
Okay, so the null hypothesis will be mu equals 295, and then the alternative hypothesis will be mu is not equal to 295.
What makes the null hypothesis you guess? What makes it the null hypothesis?
you stated that the null hypothesis always has some level of equality, and in this case, since there's an equal to sign there, I think that would be the best.
So try and master this. All of you should try and master this one by one. Now let's see whether any of you can do this one. According to the CEO, the new BMW car can run more than 25 miles per gallon. Think through, tell me the null and alternative hypothesis. That's how you come to it.
Yeah, hello sir, can you hear me?
Yes.
All right, so
I was
we
calling
do
about
mute.
Apple.
Okay.
Okay, sir.
Yeah.
Okay, sir. So, over here, I think the word is more than, which is greater than. So the now, not the null hypothesis. The null hypothesis would be less than or equal to. So mu less than or equal to 24, and then the alternative hypothesis would be less than or equal to 24. I don't know if you got me.
No, you are wrong.
Okay, let me say it again. So the null hypothesis would be less than or equal to 24, and then the alternative hypothesis would be the opposite, which is greater than or equal greater than 24, sorry.
This is how it's supposed to be. In this case, when you look at the sentence, if you have to go by the sentence, the alternative came first. So you should note that it's not all the time that now will come first from the sentence. Sometimes the alternative will come. To master these, there's quite a number of them. Master them, master them. Okay. There are also two kinds of error, type 1 and type 2 error. Okay. Type 1 is when you reject the null hypothesis wrongly. Okay. So let's say that the null hypothesis is what should be accepted, but you have rather rejected it. Then you have committed it. Now, please note that the type 1 error is a level of significance. In other words, the type 1 error is an alpha. Is a level of significance. Now, type 2 error is wrongly accepting the null. So the null is wrong, and yet you accepted it to commit it. We'll learn deeply on this, in the course of time. Okay. The type 1 error is the most serious of the two errors. So that's it. So anytime you are doing a yes, Abaka.
Sir, please, can you come back again with the substance that you mentioned? I didn't get you. Sorry.
For
the type 1 and the type.
The type 1 error is wrongly rejecting a null hypothesis. The null hypothesis is wrong. So the null says that all university students are girls. It's a wrong. And then when you did your analysis says that you should accept it. Oh, sorry. Let's assume that the now says that university students are male and female. Okay? That is true, but then you rejected it. Okay? You rejected it. If you reject the null hypothesis, you have made a mistake. You committed an error. You committed an error because truly university students are male and female. So why do you reject it? Rejecting a correct null hypothesis is committing a type 1 error. Or incorrectly rejecting a null hypothesis is committing a type 1. So another thing is when the null is rather supposed to be what do you call it? When the null is supposed to be rejected and you rather accept it. I don't know whether that's the same thing that I said before. But the second is when the null is rejected. So let me go back to the first. So the first one is when the null is supposed to be rejected and then you didn't reject it. What am I saying? When the null is supposed to be accepted and then you wrongly rejected it. That is a type 1 error. And a type 2 error is when the null is supposed to be accepted and you wrongly rejected it. So just take note of the type 1 and type 2. That's what I mean. There are errors and you want to ensure that that error is something you don't commit in statistical hypothesis testing. Okay, I'll take you through the steps in hypothesis testing. I've just gone through step 1. Okay. Remind us of step 1. Step 1 says that formulate the null and the alternative hypothesis. I've gone through that with you with a lot of examples. I'm going to go through step 2. Step 2 says compute the test statistic and find the critical value and compare the two. That's step 2. Compute the test statistic. A, find the critical value. B, compare the two. C. So that is step 2. All of these are step 2. So how do you do step 2? Well, to do step 2, that is to calculate the test statistic, you must have a sample. Okay, you must have a sample. Now, there are 2 statistics you can use. One is a t-test and the other is a z-test. The formula are there, but don't worry, I'll go through an example with you. So when do you use the T and when do you use the Z? You can tell me. If you know, you know. If you don't know, you don't know. When do you use a T and when do you use a Z? Anybody? You use a T when the sample size is less than 30. Write it down. You use the Z when the sample size is 30 or more. Take note. So that's it. T is below 30. Z is 30 or more. So when you go through the question and you saw that the sample size is less than 30, then you are tilting towards T. But you also need to know the level of significance. Remember I told you that there is something called alpha. Let me explain it now. Anytime you are doing a research, you are likely to make a mistake. Let me repeat. Anytime you do a research, you are likely to make a mistake. That mistake that you are expected to make, that error that you're expected to make is known as the alpha. You're expected to make an error. Okay, but the question becomes, how much error are you expected to make? For example, you guys know that if you are in the university and you are doing a course, you are expected to pass, isn't it? You're expected to pass. How many percent do you need to have for it to be considered as at least you are passed? Who can tell me? How many percent? You see, I'm now quoting the whole thing in percentage. So what is the expected passing rate? Anybody? Do you guys know what to mark to get a pass? Amina? Stella?
Is that 50%?
Good. So you can see that 50% becomes a threshold or the benchmark. So anybody below 50, you know you are failed. Anybody above 50, you know you have passed. Now, alpha is like that. Alpha is the error that you are expected to make. And there are three of them. You are expected to either make 1% error, 5% error, or 10% error. You are not expected to go beyond that. And so this is a threshold. So, but that's expected value. That's expected error. Now, if you have done accounting before, anytime you have an expected value, you must also have what value? Don't say unexpected. If you have an expected value, you are supposed to also have what value? If it is not expected, is what? Actual. Actual. That's what it is. Actual. So actual is called p-value. Literally. The p-value is the actual. So the p-value is the error you actually make. And then the alpha is the error you are expected to make. Write it down. You forget. The p-value is the actual error. Then the alpha is the expected error. The alpha, which is also the level of significance, is expected. Now, which one should we want it to be smaller? Should it be the alpha or the p-value? Which one should be smaller? Always. Which one are we hoping it is smaller? Ivy?
The actual.
Why?
Because that's in simple terms, that is like your actual result, and you're expected to produce like a lower error as compared to
as compared to
so if there is like a limit for you, that's the cap. You are expected to produce a lower error than what is set. The actual like the how do I put it? Like the benchmark sort of. You are supposed to do lower than that.
No. It's well explained. Now, what this means is that because your p-value is supposed to be smaller. Why? And the reason is what she said, because you want to reject the null hypothesis. Note that down. When the p-value is smaller, you now have enough evidence in favor of the alternative. In other words, you have enough evidence to reject the null hypothesis. Now, why is our goal to reject the null hypothesis generally? The goal is to reject the null hypothesis because the null hypothesis was a statement not made by you. The null hypothesis is an authority statement. The null hypothesis is an authoritative statement. Authoritative statement. Authoritative statement. It's coming from somebody. For example, the Electoral Commission will say that NDC will lose the next election. That's a serious statement. It's an authority statement because it's coming from the Electoral Commission. So Kwaku Bakun or Kwesi Pratt will try and dispute that. So what they are doing is they are gathering their T statistic. They are gathering T statistic. But they are likely to make a mistake, isn't it? They are likely to make a mistake. The mistake they are expected to make is the alpha. The mistake they actually make is a p-value. So the moment Kwaku Bakun makes a smaller p-value, then he now has enough evidence to reject what the AC said. This is how the entire research is based on. So research is based on to disprove what an authority has said. And so you are usually in favor of the authority. All right, all of this is a theory. Let's get into practicals. Down we go. In the process, remember that I spoke about the test statistic. We also compare that test statistic with the critical value. And to do the critical value, you need the following. You need something we call the degrees of freedom. The critical value is a value you obtain. That's a benchmark, by the way. It is a value you obtain at the table. So sometimes it's called the tabulated value. I'll show you that very soon. And then you can now compare the p-value with the alpha, or you can compare the critical value with the test statistic. Now look at the rule. The rule is that to reject the null hypothesis if the p-value is smaller. Remember, the p-value is also an error, and it is a smaller error than the expected alpha. Very good. Now, either you use that to do your conclusion, or you will use the test statistic against the critical value. And you always want the test statistic to be bigger than the critical value, for you to reject the null hypothesis. For you to reject the null hypothesis. The null hypothesis is the authoritative statement that you want to. Very good. Now, let me ask you a question. If you look at Jifa either, Jifa, Dave, and Ben is either. I have put something in the table. Yes, in the group page. Who has seen it? I put something on the table. Wallace.
Yes, you put the table.
Yes, the table. Do you guys see that table?
Yes, sir. The Z table.
I don't want you to be reading from mine. I want you to fill it in yours because you use this thing in exam. So it's very important to know. We are going to use this to determine the analysis. So ensure that you've opened it, all of you. Ensure that you've opened it. And I'm going to use this example to clarify everything step by step. At the end of this example, if you don't understand, you ask. You ask. So this is where you ask, not when we are done, but while we are doing it. I want somebody to read the preamble for us. This is a past question. I'm going to use that step by step to explain it. So I want somebody who has not spoken today to read the story on your screen. So you do that. You do that. You haven't spoken about today. Anna, right. Anna, you raised your hand, or it was a mistake. Who can read the person who
So I
has...
was reading, I thought you could hear.
But you are muted.
I didn't know I hadn't muted myself. I unmuted myself. Suppose that you are thinking of taking over an SME. The current owner claims the weekly turnover of each existing SME is not different from 5,000 Ghana cedis. And at this level, you are willing to take on the SME. You would be more cautious if the turnover is below this figure. You examine the books of 26 SMEs chosen at random and find that the average turnover was 4,900 Ghana cedis with standard deviation 280 Ghana cedis. What would you do? Formulate the null and alternative hypothesis and conclude on what you would do.
Excellent. Who can tell me the story? Because this is where you always have to understand the story. Do you remember the simultaneous equation word problem? There used to be stories like this, where you have to put it in word properly and then convert it into maths, and then you can solve it. So what, at the end of the day, what are you planning on doing? You. What are you planning on doing? Who can tell me? What is your goal here? What is your goal in this storyline? What is your main goal here? In fact, if we were to use one word, what is your main goal? To do what? To do what? What is the goal? Someone is selling you a company. What is your goal? Yes, Stella.
to ensure that you make a good decision.
Yeah, but not exactly. What is your main goal? What's your main goal, guys? At the end of the day, come on.
To decide whether or not to buy the SME.
Excellent. You see, you spoke once and the spirit has entered into your brain. You spoke once by reading, now you are participating in the answer. And that is exactly the answer. Your goal is to buy or not to buy the SME. That's the goal. You are not sure. The owner says that he will sell the SME to you at what price? The owner says he will sell it to you at what price? Or let me put it, the owner says that if you should buy the SME, every single week, you're going to get how much? The owner says that every week you get how much?
5,000 Ghana cedis.
5,000. Now, if it is 6,000, will you be happy or not?
Yes.
If it is 4,008, will you be happy?
No.
So that is why your sentence was cautious. You're going to be very careful. If the price is below, you will be very, very cautious. Very, very cautious. If the turnover is below that 5,000. Now, somebody has made a claim. The owner made a claim. The owner says you get 5,000. So the owner has made an authoritative statement, the null statement, and you want to debunk that. Well, it is not on the owner to actually go and gather the books. So what you decided to do is that because you are not so sure whether what the owner is saying is true, you went around looking for similar SMEs in town, and you collected how many SMEs? How many SMEs did you finally get?
26, sir.
26. Yeah.
I don't know if now you are mentioning the answers in the air. Meanwhile, the difficult question, you don't mention the answers in the air. Life can be sweet. So you collected 26 companies and then you calculated the turnover for each of them. Some of them, the turnover was 1,000. Some of them, the turnover was 7,000. Some of them, the turnover was 9,000. Some of them, the turnover was 3,000. But on average, you got turnover of what? On average, how much did you realize was the turnover? Valentina.
4,900. 4,900, sir.
Abraka, I think I have to meet you because you don't listen to rules. You made a mistake of shouting the answer first. Now you are not obeying them. All right, so you go for the 900. How do you start this? The first thing you do, follow me whilst I do it, is to identify the elements. Listen carefully. The elements of the question. So we are going to identify the element of the question. The first thing you got to identify is known as mu. Mu. This is a one sample hypothesis. Mu. The second thing you need to identify is the X bar. The third is the sample size. The fourth is the standard deviation. And the standard deviation, you have to decide whether it is small sample you are dealing with or big sample. So let's start with the mean. Now, there are two means here. The first one is a population mean, and it's represented by mu. The population mean, and it's represented by mu. Okay. Who can tell me the value of the population mean in this question? What is the value of the population mean, mu, in this question? Because whatever you choose, I'll ask you. Why do you think that is a population? Just to give you a clue, the population mean does not have the standard deviation following it. The sample mean always has the standard deviation following it. So when it comes to the sample mean, anytime the sample mean is mentioned, it will be followed by with a standard deviation of, and the standard deviation of, and the standard deviation of. So the sample mean has a standard deviation from it. But the population mean, you will not get the standard deviation for it. So on the basis of this, which one is the sum? Which one is the population mean? Naya.
It's say 5,000.
Why?
Because with this one, when you read the question, it says the current owner claims the weekly turnover of each existing SME is not different from this. So, and as you stated just now, that's the sample. What was the question there? Sample mean or something like that. So follows the standard deviation. So I assumed it was the 5,000.
Next time, write it down.
Yes.
Next time when you write it down, you're not be confused as to it. Okay. But your idea is good. Your idea is good. So let's go back. The population mean will be 5,000. So we write 5,000. What is a sample mean? The X bar. You can tell us. What was a sample mean? I don't need to go back to the story. Mama, what does a sample mean?
4,900.
Very good. So you write that one too down. What is N? Can tell me the value of the letter N. What does it stand for? What does the N stand for? What does the N stand for? Google.
So the N stands for the samples population. So the sample size,
Sample,
which is 26.
yeah, but it's not called sample population. It's sample size.
Yeah, sample size I said.
Okay, so the sample population you said was a mistake.
Yeah, I said sample size. After I said the first one, I explained.
That's my question. Which one should I take?
So please, sample size.
The sample population wasn't correct. That's why you corrected us.
Yes, that's why I corrected myself.
All right. Okay. So now looking at the number of the sample size, are we going to use the T statistic or the Z statistic, guys? Looking at the number, are we going to use T or Z? T or Z? Shadow, Amina.
So please, we'll use the T.
Why?
Because the sample size is less than 30.
Very good. What is a sample standard deviation? You can tell us the value of the sample standard deviation, which is this case. What is the value of the sample Stella?
$280.
Right. So these are the items you need to proceed with your hypothesis. Okay, now we are ready to do the hypothesis. So we're going to write, remember, you always use the null hypothesis. Sorry, you always use the population mean to write a null hypothesis. Write it down. Always use the population mean to write the null hypothesis. Always use the population mean. Okay. So that means that we are going to be using the 5,000 to write the null hypothesis. So you write mu, then you leave a space, and then you write 5,000. That is 5,000 done. And then you write mu again, you leave a space again, you write another 5,000. Question: what symbol should come in between based on the storyline? What is a symbol? What is a symbol that will come in? Theophilus.
So please, equal to.
Because of which word?
It's not different from.
Very good. But then you don't have to write that. You don't have to write it's not different from. What actually should you write? Which one are you going to put down first so that there's no confusion? Instead of writing fully that it's not different from, ideally you would have written what? Different from. That's what you would have written first. Different from. And the symbol for different from is what? You can tell us. What's the symbol for different from? Stella.
Not equal to.
Very good. And therefore, its opposite is equal to. Which one is a null? The top one or the down one? You can tell us. Which one is a null? The top one or the down one? Rama.
Sir, it's the top one.
Very good. So you write H naught for the top one, then you write HA for the down one. All of these are going to give you marks. Okay. Now you need to think about what you've written and say it in English. What is the top one saying? Really speaking, what is it saying in English? You can tell, you can guess. The top one, what is it really saying? What is it really saying? Practically speaking, related to the story, related to the preamble. What is the top one really saying? Anastasia.
No, please, I'm trying. So, and the top one is saying that the population mean will give you 5,000 Ghana cedis.
Right. But let's get a better one. What is the top hypothesis saying?
Okay, so the SME you take over, you'll be getting a turnover of 5,000 Ghana
If
cedis.
you were to write it down, well, how will you write it? How will you write it precisely and concisely? Think about that. Let's go to another person who will tell us how to simply write it. There's one way you can write it. One, you can say that the weekly turnover is 5,000 Ghana cedis. The weekly turnover for the SME is 5,000 Ghana cedis. The alternative would be that the weekly turnover is not 5,000 Ghana cedis. Now, guys, let me ask you. If you say that the weekly turnover is not 5,000 Ghana cedis, it presupposes that the weekly turnover is what? Is it above or is below? Valentina.
Sir, it could be either above or below.
No, technically speaking, it couldn't.
Okay, technically speaking, to be less.
Exactly. You see, not technically speaking, and yet you're trying to do jagalaga. Yeah. Now, this requires knowledge, and you've done well for choosing that side. Technically speaking, the alternative of it not being 5,000 is it being below. Why? Because that's alternative. Because anything 5,000 or more is in favor of what the owner is saying. So the alternative will always be what the owner is not saying. And what the owner is not saying is not going to be the above 5,000. It's rather be the below 5,000. So this is a very critical way of looking at it. Okay. Another way of thinking deep beyond, and this is where I give more marks, is recognizing that this first part is saying that buy the SME. You realize that? This one is actually saying that buy it, buy the SME, isn't it? Can't we say that?
Yes.
Yeah. And this second one is saying what?
Don't buy.
Exactly. But of course, behind the between you and I, we know behind the scenes why you shouldn't buy. Because this alternative is actually saying that the turnover is not really 5,000, but it's rather below. And so, don't buy. So the first one is saying that nothing prevents you from buying the SME. The second one is saying that the owner is a liar. The SME is bogus. The owner is a liar and the SME is bogus. All right. So that's step one. Step two is now to calculate the test statistic. You have already said that we are using T statistics. So T statistic is given by if you can remember, it is x bar minus mu, take note, divided by s divided by the square root of n. This is the formula for the t-statistic calculation. And now we know all the values. So I want you guys to substitute the values. Use a calculator and tell me the actual value of t. Who has finished? Substitute each element and tell me the actual value of t. Remember, we are calculating the test statistic, after which we shall compare it to the critical value. So in principle, what you're actually doing is that, yes, Naya.
It's
Correct.
actually
Basis.
2 decimal places. Okay, so it will be approximately negative 1.82.
Approximately.
Yes.
Approximately. Very good. Do you all have that? Did you all have that? Or sometimes somebody will say that, well, now that she has already told me the answer, then I don't need to work it. Anyway, so that's correct. If you do that, you're going to get negative 1.82. Negative 1.82. And it is positive as well, because the normal distribution, whatever is on the left-hand side, is the same thing that is on the right-hand side. It's symmetric, it's a mirror image. So you can make it negative or positive. So I can just use an absolute value to indicate that it's positive. Okay, so you've got the null hypothesis. Sorry, you've got the t-statistic. The next thing is to find the critical value. The critical value is given by t subscript alpha subscript n minus 1. That's how you work it. N minus 1 is called the degrees of freedom. Note that. N minus 1 here is the degrees of freedom. So what is n minus 1? You know the n, you know the 1. What is n minus 1? Anybody?
25, sir.
25. Now, what is alpha? Alpha is one of these three things, 1%, 5%, and 10%. Whenever alpha is not given, the default is 5%. Write it down. Whenever alpha is not given, the default is 5%. Therefore, our alpha will be 0.05, and then 25 minus 6 minus 1 here. Sorry, 26 minus 1, because the sample size is 26, so you get 26 minus 1, giving you 20. So remember, the degrees of freedom is 25, and then the alpha is 0.05. Now, remember the tail we are dealing. Looking at the top here, and the null hypothesis, and checking the symbols, especially always the alternative, which tail are we generating? One tail or two tails? Which tail do you think we are doing? One tail or two tails? Come on. Ilama.
Yes, sir. 1 tail.
No, it's not one tail. It's two tails. Tell you that is your.
Sir, please, can I ask you a question?
Yeah.
Hello, sir.
Yeah, go ahead.
Okay, sir, please, can you please like clarify why it's two tail? Because you said that
Because
if we
it's a two direction. I indicated that anytime you have this symbol, this symbol can go either way. And whenever the symbol can go either way, it's a two tail, because the principal symbol here, principally, it can go above or below. even though we've practically concluded that it's going to be below. But
Oh,
the
okay.
symbol is above or below, and this symbol makes the thing a two-tail. If we had deliberately used less than or deliberately use any of the other symbols, then it would have been.
Okay, so it's not about the symbol, it's about what you are trying to conclude.
It's about the symbol.
No, I mean that, no, I think I'm twisting it. So I think my confusion was coming from the fact that because we had practically concluded that the figure
It's
has
not
to
based
be
on the practical
below.
conclusion. It's based on the symbol.
Okay.
Okay. So now we know that our alpha is 0.05 two-tail, and our degrees of freedom is 25. This is called a critical value, and you have to, it's also called a T tabulated or the tabulated value. So you have to go to the table and read it from the table. Keep the numbers in mind. We are going to go to the table. At this stage, I need to wipe out everything. Keep the numbers and the answers in mind. So we're going to go to this table here. And remember, we are going to find the critical value. How do you find the critical value? Remember, we had 0.05, two-tail. So when you come here, at the bottom here, you see two-tail. Okay. Two-tail, which means that all the numbers down here, the bottom numbers are all two-tail numbers. And then the ones at the top here, they are all one-tail numbers. Now we are looking for 0.05, two-tail. And when you look at the two-tail, the 0.05 something. Good, we got it. And we are looking at the degrees of freedom. The degrees of freedom are the numbers here, as you can see here. So all the numbers down here on the far left, they are all degrees of freedom. What number for the degrees of freedom are we looking for? What number for the
25.
25.
25, sir.
So I want you to select the 25, match it against the 0.05, and then tell me the corresponding number. That number is the benchmark. That number is a critical value. You can raise your hand and tell me the number. You can raise your hand and tell me the number. Everybody has eyes, and I'm sure you can all see it. So who can tell me the number? When is that?
Say 2.060.
Exactly. So this is the number, right? We are going to get 2.060. Therefore, we can conclude that the T statistic is negative, or absolute value is 1.82. That's a T statistic. And the critical value is 2.06. So at this stage, we are going to compare. How do you compare? Now remember, and here is a rule in case you didn't know. The rule is that reject the null hypothesis, reject the H naught if the test statistic is greater than the critical value. Write it down. It's already used. If the test statistic is greater than the critical value, then reject the null hypothesis. And by the way, like I said, the test statistic will take the absolute. So let me ask you all, are we going to reject the null hypothesis in this example, or we are not going to reject? Are we going to reject, or we are not going to reject? Anna?
Sir, please, I raised my hand to ask a question.
Go ahead.
Sir, about the table, if you could go over how to determine the number, the answer.
Okay. So you remember that before you can determine, you know the value of the T at 0.05, and then we also had 25, remember?
Okay.
So those are the two you are going to use to determine the critical value.
Okay.
The 25, you select it on the far left, which is here. 25. Far left. That's called the degrees of freedom. And then the 0.05, remember we said it was a two-tailed. So when you look down here, these numbers are showing two-tails. So you look throughout to see 0.05. See, this one is 0.02, 0.002. That's not correct. 0.01. That's not correct. 0.02. That's not correct. But 0.05. That's the correct one. So you start coming down here, and you start going right here. And where the two of them will meet, that becomes your critical value. Does that answer your question?
Yes, but I'm wondering why he said 2.064 instead of 2.060.
It's 2.060. Is that right? 2.0. Is that what you said?
No, I said 060.
Yeah, I think I mistakenly wrote 064. It's supposed
Okay.
to be 2.060. Yeah. So
Okay, thank you, sir.
all right. So now you have to make a decision. Remember, the final step is to decide and conclude. So the decision is deciding whether or not to reject the null or not to reject the null. What is going to be our decision, Stella?
So we would not reject the null because the test value, the test statistic is lower than the critical value.
Excellent. Guys, she's right. She says that this test statistic of, always mention the number. Yeah. Don't just say it. Always mention
Okay, so the test statistic of negative 1.8.
Drink water. Drink water.
Yes, sir. So we would accept, we would not reject the null hypothesis because the test statistic of negative 1.82 is lower than the critical value of 2.060.
And always add the level of significance. Add that, add the 5% level.
Okay, so at the 5%, the degree of
have you eaten?
Not yet, sir.
You have tried. The way Amina is wild to change your answer. Okay. Now remember.
Oh, sir. Sir, please, I have a question actually. Hello.
Go ahead.
Okay, so sir, the level tabulated value, there is 0.05. I don't know how, maybe my network broke or something. I didn't realize how it came about the value
It was here.
for the 5%.
It was the alpha. You always need the alpha level. That's the level of significance. But in this very question, it wasn't given. And I did mention that anytime the alpha, the level of significance, because sometimes the question will say that take alpha to be equal to 5% or 1% or 10%. Sometimes it will rather put it in a sentence and say, take alpha to be equal to 10%.
Okay.
If it doesn't say anything like that, you should automatically assume that alpha is 5%.
Okay. Okay,
Like
sir.
this question,
Thank
we
you.
assume that alpha, and that's what you will always use to calculate your critical value together with the degree.
Okay, sir. Okay, sir. Thank you.
Now, what you do is that you now conclude, which is what your friend has done very beautifully, that since the critical value 2.09060 is rather bigger than the test statistic of 1.82, at a 5% level of significance, we reject the null hypothesis. That's what she said. We reject the null hypothesis. This is called decision. But we have not concluded. So what is going to be the conclusion? Practically, now we have to connect it to the SME. You got to now speak to management. What is now the conclusion? Who can conclude? Given the fact that we rejected the null hypothesis, what to be the conclusion? And this one, I need brain. I need brain work, not guesswork. Brain power. You okay?
So please, I'm sorry, I have a question. I just wanted to be clear on something. Initially, you state that if the test statistic is greater than the critical value, then you reject the null hypothesis.
Yes.
Okay. I just wanted to be clear, please.
Yes, that's the rule. In this very example, it was not greater. That's why we could not reject. Okay, Nanaya.
Okay, I also have a question. So, I mean, coming to or concluding and coming to your decision, as you said, the test statistics, in this, when you are trying to get your conclusion, let me put it that way, do you get rid of the negative sign? I
Yes,
don't know
you
if
always get rid of.
I should always get rid of the negative
Yes,
sign.
you use the absolute value.
I should use the absolute value. Okay.
All right, Valentina.
Okay, so then your last statement on we rejecting the hypothesis would be wrong because you mentioned that if the rule is that we reject if the test statistics is greater than the critical value, but in this case, our test statistics is actually less than our critical value, so we will not be rejecting the hypothesis.
I said we would not reject.
So we don't
Yes, but I'm referring to Doc's last statement that he made, not the answer.
So
Just
I'm
drawing
saying
his
that.
attention.
Okay, so yes, Ebenezer.
All right, so if we are not rejecting the null statements, that means the weekly turnover for the SME is indeed 5,000.
Excellent. So what would be your advice?
Say we should buy it.
Exactly. I love that. Because you connected it. You should buy it. So another beautiful way of saying it is that nothing prevents you now from buying the SME. So what does that mean? The owner of the SME who was selling the SME to you, what would you say about him?
So it's trustworthy.
That's it. You are thinking, oh my goodness, this guy is smart. Okay? It means that the owner is trustworthy. You see, you are connecting everything to practical analysis, not just calculating mathematics and statistics and going to bed. But now you've connected it to practicality. So that now we can go ahead and buy the SME. Now the owner is trustworthy. Very good. That's how you conclude. So this is managerial advice, policies coming out of your statistics. Statistics are meaningless unless you make meanings from them. That's it. Now remember that we concluded using the critical value versus the test statistic. That is another way you could have. Another way we could have concluded, everything is here, by the way. Another way we could have concluded is rather not using the critical value versus the test statistic, but rather using the p-value versus alpha. Write it down. So we are going to pick the p-value and pick the alpha and compare them. Now, let me ask you guys, which one are we hoping that it is smaller? Which one are we hoping it is smaller so that we can reject the null?
The p-value.
So if we go and calculate and the p-value is rather bigger, then it means that we don't have enough gravitas to reject the null hypothesis. That's what it means. We don't stand the chance to go against what the owner is saying. The advice I will give you here is that the p-value approach and then the other one, the first one, the critical value approach, it will always lead to the same conclusion. Just keep that in mind. Okay. Now, we already know that the alpha is what? 5% by default. What is a p-value? Write this down. Always use the test statistic to find the p-value. Write it down. Always use the test statistics to find the p-value. So what is a test statistic? What is the test statistic?
1.82, sir.
1.82. 1.82. Now, if 1.82 is a, if you have 1.82, what you're going to do is you're going to take this 1.82 and dump it to the swimming pool. So you remember it's 1.82. We already know this. You pick that value and you go and drop it, boom, into the swimming pool. Boom, into the swimming pool. So how should we do it? How should we do it? How should we do it? So take this into the table. I just want to take it to the thing. And guys, watch what you're about to do. You're going to take this 1.82 and you will dump it boom here, this swimming pool. So what you're going to do is that you are going to look for the number. You're going to go through with your eye. But it's not difficult because we climb. The numbers are climbing from the top to the bottom. And you're going to look for a number or two numbers closest to 1.82. Let us start searching. Start searching for a number or two numbers closest to 1.82. And these two numbers, one should be on top of the other if there are two numbers. If it is one number, fine. But if it is two numbers, one should be on top of the other. Who has found one of these two numbers? Go through, comb the swimming pool and find a number closest to 1.82. So let me ask one of you who has found it. Amina.
So, sir, 1.833 and 1.812.
Fantastic. Adute, is that the same number you had in mind?
Yes, sir.
I was looking at, okay, yes.
Hey, Master, you've changed your mouth. That is
Yes,
the
sir.
number. These are
That's
the
the number.
only two numbers that are closest to 1.82. They are guide. Once you find these two numbers, they are not the answer. Remember, we are looking for the p-value. So you climb up, and then go and take these two numbers, one of them, the one that is two-tailed. Which one is two-tailed?
0.10, sir.
Exactly, the 10% one. And that is your p-value. Therefore, our p-value is 10%. So remember, our alpha is 5%. Then our p-value is 10%. Should we reject the null or we don't reject the null? Should we reject the null hypothesis or we don't reject the null hypothesis?
Reject because p-value is good.
Do we reject, Amina?
Sir, please, we do not, because the p-value is 10%, which is equal to 0.10, and alpha is 0.05, which means it is greater than the alpha. Therefore, we do not reject the null hypothesis.
So does that agree with the previous one?
No.
I already told you that it must agree with the previous one all the time. But you said no. Does the conclusion agree with the previous one?
Yes, sir.
Yes. Because we are, yes, we have made too many mistakes. Look at the p-value. We made p-value an actual mistake of 10%, more than what we are expected to make, which is 5%. Yeah. It means that we don't stand a chance of rejecting what the owner is saying. The owner is making a null hypothesis statement. We gathered information. We collected the books. We looked at 26 companies. We've checked it. We've made a mistake of 10%. We don't stand a chance of rejecting the null hypothesis. Therefore, nothing prevents us from buying the SME. The SME must be bought. What the owner is saying is the truth. This is how. So this one is just validating what we did already. It just validates. And it has. We have made too many mistakes. And therefore, we just have to listen to what the owner is. So that conclusion is also here. I did that conclusion. You see the way I've written how you should find the figure 4 between 1 point, blah, blah, blah. As I scan the body of the table, the swimming pool. And then I said, either way, you get this one at the top. And for the truth tail. Therefore, you conclude that since the p-value is 10%, which is rather bigger than the alpha, we don't reject the null at the 5% level. And so nothing prevents you from buying X. That practical conclusion alone is 8 months. Because at the end of the day, your understanding is important than just calculating. Any question? Any question on how to do hypothesis testing for one sample case like this? Now, this is another example. A standard manufacturing process has produced millions of TV tubes with a mean life of 1,200. A new process recommended by the engineering department as better produces a sample of 100 tubes with a mean life of 1,265 hours and a standard deviation of 300. Test the engineering department's claim. Assume the confidence interval is 95%. Now, if you are to assume the confidence interval is 95%, it means that the alpha level is what? Rama?
Sir, 5%.
5% is the answer. So please know that sometimes they will use confidence interval to confuse you. But all you got to do is to subtract it from 100, and that is the alpha. If the confidence interval is 99%, alpha is what? Alpha is what? Salah.
0.01%.
So you can go through this analysis on your own and then be able to come out with some beautiful conclusion that is right here. This is another example. The Ufiashom is a tomato grower. And this time, you have been given the sample. You see, normally they will give you the population mean. Look at this one. It says that his claim is that the average yield per plant is 4 kilograms. Okay, so this 4 kilograms is the population. That's what you use to form the hypothesis. Now, a gardening magazine has tested this claim and obtained a standard deviation of 0.69. But you are the one to use this data and calculate the mean. So you have been given the data, so you need to find the mean, that is the X bar. This one is a mu already. So you have to calculate the mean. Finding the mean here is very easy. All you got to do is add all together and divide it by the sample size. So this one is actually equal to, the sum of all of them divided by the size. find all. Then once you get the mean, you use that to find the x minus the mu divided by the s divided by the square root of the sample size, which is n. And the sample size is 10. So this is 1, 2, all the way to 10. The question is, does this data support the Ufiasem's claim? He is claiming that the average yield per plant is at least 4 kilograms. So he's actually trying to say that the plant is big. It's like saying that the mango fruit that I'm telling you to buy is not a joke. It's 4 kilograms. It's very big. It's very big. The question is whether that is true. We collected a number of mango, some of them are above 4 kilograms. Some of them are also below 4 kilograms. So what do you do? What do you do? What you got to do is to calculate the average, compare the average with the population average. And then, given the standard deviation, calculate the test statistic, compare it. So all of that information is also. Work it. I've given you the solution to them. Go through it. And then, if you have any question at any time, ladies and gentlemen, any question, please? Any question related to what we have done? Roma.
Yes, sir. So it's not really a question. I just want a clarification on the wording. So you see, you kept saying that we do not reject in writing the conclusion. We do not reject it. Is it okay if I write, because we are not rejecting the null hypothesis, is it okay to write the null hypothesis is accepted?
No.
Can you put accepted? Okay. I wanted that clarification.
The reason is because of the probability of committing a type 1 error. See, when we accept a null hypothesis, we rule that. You see, when we are rejecting a null hypothesis, it is okay to say that we reject because the possibilities are many. But when you say we accept, you rule out possibilities. And so you don't want to commit, because the probability of committing a type 1 error is rejecting a true null hypothesis. And so because of that, you using acceptance is a very, it's not a statistical statement to say. It's not a responsible statistical statement. So just say we reject or we don't reject. Any other question, please? Very good. So, like I said, this brings us to the end of the entire tableau.